Father. Yes. Might be any question so far? How it works? Okay, this things. Yes. and sentences. Let's say I will add it here. Let's say I want to drive my car. For example, this is the one, and next one will be I love to drink, and third would be I love to eat a pizza twice a day. So what can you say about let's go one step further. So let's go by in we have our hidden in which we store all the data, basically. Then, yep, no. Is it morning or you're just tired? Okay. Now, if no questions about that, let's see how this one, this one here, this one, how it looks like, one single unit. Okay, okay. Oh, this one is not. So, right now, your template, I will switch to my chart. We have our template open. Um, one moment, I will check out whether you have some kind of. No, that we have. So today we're using computer network traffic, bless you, and what we have inside. we have imports. Let's close them. We have some functions, pack, pad sequence, and packed sequence. Those are uh, I have pack, pad sequence. To do it a bit by hand. So we have our arguments, captcha with the height, length, model size embedding, model hidden size, blah blah blah, num epochs. How many symbols captcha we have? So yesterday we had 4 symbols, so A, B, C, D. Randomly generated. But this is, I guess it's the yesterday or for the further task. We have our class dataset. We're loading it as the PDF or as the we're loading CSV file, reading as a pandas. So we have all data in one place, like an Excel spreadsheet that is called data frame. We group them, and then we perform some encoding operations. Blah blah blah. Replace IPs with indexes, so we would not have next one, we are normalizing it. Yes, we are performing the normalization operation and adding it to the standardized sequence. So we have 847 samples, 96 max Q sentence left, and 2 input features grouped by date and IP address, maintain energy, flows per day, task detect suspicious activity at this date. Okay, so we do not need that now. Init OK, len OK, get item. We get our row sequence. We move array by one position, get x padded, y padded. So now we have same size for x and y. We append x and y inside, and we return x padded, y padded, and length of x, initial length of x. Okay, this is okay. Next, we have data loaders inside. Data generator, train loader, test loader, RNN torch, and our model. So we have today to code inside the RNN. Model is already given. So let's check out the model. We have embedding, embedding. So what means embedding? One click where, no, I haven't added it. Uh, there were a bit PyTorch, PyTorch. This one. Here is the better representation how it looks like in the we now know what is embedding. So we number of embeddings, we need how many IP sources we have, and the model embedding size. We have our RNN model. Input parameters are input size, hidden size. So I will just add it input size, hidden size. Yeah, we can hidden size. We have linear layer to perform a classification. So output would be hidden size and count of IP plus 1, probability of each IP plus 1 for the flow. And we have forward loop. We have X as packed sequence. We perform forward loop of the model. We zip embeddings with the data, again packed, perform RNN, classification, and I pack and unpack them and return. Let's just see how the model or how the data looks like. So let's put a breakpoint. Good question. So let's just see how the input of the model look like. So we have X, which is sequence. So what we have inside data. Next one is embedding. The next embedding we have already is embedding forward. Embedding. So I get here by we embedding the number of embeddings. So as much as we have dataset full SP source IDs, as many you see them, yeah, 2005, and model embedding size is 4. So for each number of reading through the data, I can say that we can we see what's inside the self-embedding? Self-embedding plus we have embedding 4, norm, number of embedding 2005, and weight parameter. Weight for each embedding. Yeah, okay. We are packing them, performing packed sequence, so pack them, RNN through RNN, through forward to perform classification, pack them back, and pass again to Y prime and current hidden state. So current memory of the recurrent neural network. So prediction and memory. As the on the chart was input some kind of, so in our case IP and the number of flows, and output IP and the number of flows and current memory. So is this clear? That we give what we give inside and what we give outside. Might be it's not clear from the case from the point of embeddings, but from the just point of no. You understand that? Okay. I hope I will find something more how to describe those embeddings better. But from now, let's check out. We do not need model now. The rest of the code seems okay. There might be some small bug that we'll fix a bit later, but let's go to our RNN, hidden size. Okay, what do we need? We need standard deviation, so STDV. So how our data is located on the overall graph. One math SQRT hidden size. So this is our standard deviation based on the hidden size. Then, as we have previously, we need two matrices. So here we can see we need one matrix, we need second matrix, and we need third matrix. So let's put them out. Self v for x is equals torch and then parameter. I won't define the size yet, so you will say me what size should it be, but we need to initialize it as uniform. So from how was it, uniform, like that? Yeah, from minus stddef till plus stddef. So we have one parameter. We can press Ctrl D. We will copy it and create the same for the hidden layer. And we can Ctrl D, but removing the uniform, since it's the batch size 0. And this one would be for the batch size. BH. Batch size for the hidden layer. So we have weights for the input layer, we have weights for the hidden layer, and we have batch for the hidden layer. So can anyone tell me what dimensions should be weight for the input layer? Okay, you can name it just by looking at the arguments inside the init. You have your arguments. So what should be the yes. That's one of input size and hidden size. Yes. What should be for the hidden layer? One? Uh, Anyone? Which size should be the hidden layer? You have only two variables. Which one would you choose? Hidden size and again hidden size. From hidden size to hidden size. And what dimension should have the batch size? Why? If it's for hidden layer, hidden size. Hidden size. So yeah, we have defined our unexpected argument uniform from so we have our weights, we have our batches, we have our now we can implement our forward pass. We do not need that now. Let's be for a moment. We need x unpacked, so we need to unpack our x. we need to unpack our lengths, pad, packed sequence, X, patch first, true. So we have pad packed sequence. So we had previously packed our box with the sequences. Now we need to pad them to match the same sizes. So now each X would be the same size. Batch size, we need to have it as the variable. Uh, yeah, and that's why you use pad packed sequence. Pad them with the zero, with the zeros. In a moment, we will check it out. Even now, we can check it out what we are giving. Debug. So what we are getting as a X unpacked and X length. I hope that it will work till that moment. Exception. Where is the exception? Console. Argument makes upload position must be tensor, not int. Search parameter. Torch parameter, input size, hidden size. Ah, I forgot. This one should have torch and then torch flow tensor, flow add tensor, and then input size, hidden size. So please add those flow tensors. Flow tensor for both, and even for the batch. Hidden, yeah. So now they should be again. Working. Like a leaf variable request that is being used in place operation. Hmm. Okay. This one uniform. This one should be as a one row. So parameter and inside is torch flow tensor input size hidden size uniform blah blah. The same goes here. Torch parameter. This one is inside. This one is inside. And same goes here. This 0 is inside. Blah blah. Now it will work. Okay. So we have our yes, please. Jamboard. No worries. Where is my Jamboard is entered. Welcome. And now let's try it again. Oh, we have our length. So as you can see, length of the first one is 45, 2, 19, 24, 28, 20. So each of them is a different dimension, and this is how it looks like in unpacked variant. So we have 16. Length of the sequence that we have is 16, 45 by 5. So 5 is 1, 2, 5, yeah. So we have our encoded embedding plus output, embedding plus output, embedding plus output. Okay, this is okay. Then we need to finish our batch size. Batch size is equal to size 0, size 0. Then we will check, we need to check hidden. If hidden still is none, so we have no previous experience. If hidden is none, so if it's empty and we have no previous experience, we need to create it. So hidden equals torch dot float tensor. Inside would be batch size and self hidden size. So we can multiply it each. Then again, we need to initialize this with 0 and move it to our device, args device. So yeah, so now we have our hidden layer created. Hidden layer is okay. Next, we need, so currently our x unpacked dot size, how it looks like. It looks like batch dimensions, sequence, and embedding size. So this is what we have now, but what we want to have sequence in the first place. So the main object, the main tool for us is sequence. So let's do it. So we will do it as x sequence equals to x unpacked dot permute. As you remember from yesterday lecture, permute allows us to move channels, and we have 1, 0, 2. So we moved our sequence in the first place, and then we keep batch and embedding size. This is okay. We have our, let's name it list out empty list, and we need to iterate through the x samples in our x sequence. So for xt, so for x timestamp in our x sequence, so now we go from 1 timestamp second and so on and so on. We need to do calculate the first where it was the first step. So we multiply our x by weight matrix. So we need to temporary x is equals to self v with x transpose, and this one, this at means dot product xt dot unsqueeze. Will you return? Will you return? Unsqueeze by dim equals -1. So we have multiplied and too much dimensions. And then we need to squeeze it back. Squeeze dim -1. So we have our temporary x ready. Now we have to do the same thing one moment, for the hidden layer. So we need our temp h, which basically is the same thing, so you can copy it, paste, but do not forget to change vx to vh and not x and t, but our hidden layer. So now we have our x value, hidden layer value, bless you. Now we need to do our plus and tan h operation. So our hidden now will be equals to torch torch dot tan h. So we perform tan h, and now the summing. We need to sum tmp x plus tmp h plus self ph. So we are adding all those three things together. So the previous or new hidden layer, existing input, and our existing bias. So this is. Now we need to store our hidden information inside our list out. So what will be, what we will return, append hidden. This is okay. So now we iterate through all the sequence, calculate weight matrices for the x and h. We calculate our hidden value. We add it to the list, so save it to not to lose. Now we need to stack them from one large sequence, from one separate numbers to one sequence. So we have out sequence, the same as x sequence. We have out sequence and torch stack list out. So we have combined them from separate numbers to one large list. So now we have one large sequence again. We now have out what we will return. Since now we have sequence, batch, embedding size, we need to revert it back. So the same operation as out sequence dot permute, and again the same thing, 1, 0, 2. So we again change back from sequence batch embedding size to batch sequence embedding size. And we need to pack it back. So since now we have all the separates like value indexes and so on, we need to pack it back to match the packed sequence. So let's pack it something higher. Let's pack it out packet equals pack added sequence out. Again, we save our x length, so to not lose where is the our desired sequence and where is the leading zeros. Batch first true, and in for sorted false. So we do not want it to sort our internal structure. So we want as we received, as we returned. And now we need to return out packed. So delete or comment out this one line. So now you're returning back your whole sequence, whole calculated sequence. Not yet. I'm thinking of one. Yeah? Where? I think you will get error in the loss function, yeah? I have no, so everything was successfully until the loss function. So where you have a problem? 183. 183 was the problem? So do you need it in the Jamboard? Yeah. Okay. I will add it to the Jamboard. You have now RNN and forward loop. So, and now I will check out. What function, yeah? Or anyone have? As I remember, I had issues with the loss function. So loss.tce here should be close. In my case, wait, long, yeah, long. Mm-hmm. No, I'm implementing changes to make it work. So I guess we have PyTorch version. You are newer. That's why I'm adding this one too. Losses append CUDA. Mm, mm. Uh, Please use um, matplotlib dot use and tqrt, how it was called, cag matplot backend. I will just copy. Mm, nice. Qt agree. Yeah, could be. Which one? This one, yes? Yeah. So use this line to make it to do not require the. If you still experience problem, try to comment out this maxlen variable. So we still are limiting our dataset. Exactly opposite. Kag asks. Sorry. One moment. I will try to search a backend for you that is not require that do not requires input from your side. Which backend you were using previously? I do not remember. And it was working fine. AGG. So we need to find one backend that will fit all positions. It was not showing the plot. So in my case, I need either to use cag or some select macOS. Capital K. Let's check it out which backends we were using previously. We were not switching the backends. So you need some kind of to switch to change this backend to another one. So you shouldn't click every time close the window to make it work. So if you have still experience, try to still limit the dataset by commenting out max_len. Matplotlib backend. So I would recommend you to for Windows. Yes, because Jupyter is not supporting, so that's why we need Matplotlib backend. Then there is no other. So you just need to print and Matplotlib backend and try to search which one will suit you. I guess some of them. Previously we were using Tkag and everything was okay. Now maybe Tkag could be. Okay, I will try to stop, close all the windows that we have, try to use another backend. So not Tag is not key. So have you managed to run it? No? Where is the problem now? for all the previous one. I want to put breakpoint here. One, I do not know names, so one proposition was to change this amount of epoch to something greater, for example, 100, and you will do it. I mean, like that? Ah, no. One moment, I will check out. Uh, so next step, like now, I see that our hidden is not passing further. What we can do to save hidden, hidden, passing it. I will announce it the classroom, but most likely at 12, at 12 or at 1. I will make an announcement 12 on it.